Good morning, students. In the last class, we are discussing data structures. In the data structures, we are discussing linear data structure. Data structure has two parts, two types. One is primitive data structure and the one is non-primitive data structure. Primitive data structure, the data structures that are directly manipulated by machine level instructions are called primitive data structure. So integer, float, char, pointers, what we discussed in the first year, and the pointers in the second year. Then come to your non-primitive data structure. The data structures that are derived from the primitive data structures are called non-primitive data structures. In that there are two types of non-primitive data structure. One is linear data structure and another one is non-linear data structure that we have already discussed. So linear data structure, the ordered collection of elements stored sequentially in the memory are called linear data structure. The ordered collection of elements stored through the links is called as non-linear data structure. We are discussing a linear data structure. The linear data structures are arrays, stack, queues and linked list. We have already discussed array part. What is an array? Array is a collection of homogeneous elements stored in a single name. Each element of the array is accessed with the index. Index starts with 0 to n minus 1. Many operations of a linear data structure and as well as your come to your array we discussed, that is traversal, inserting an element, deleting an element, searching an element, sorting the elements and merging the elements. These are the operations we discussed along with the algorithm and 5 lab programs we discussed in the array part. Along with that, two-dimensional array memory representation we discussed. What is two-dimensional array? Syntax of the two-dimensional array, then memory representation, row major order and column major order. How to find the address of element present in the row major order and the column major order. Different formulas along with an example we discussed. Along with applications of array, advantages and disadvantages we discussed. Completely array part completed. Now we are discussing second linear data structure, that is stack. Then stack is a linear data structure. It is a linear data structure. It is a collection of ordered elements. It is a collection of ordered elements. It follows last in first out principle. Last in first out. Principle. It follows last in first out principle. Okay. Insertion and deletion is taken place at only one end called top end. Only one end called top end. Please understand the definition properly. It is a linear data structure. It is a collection of ordered elements. It follows last in first out principle and insertion and deletion takes place at only one end called top end. That means your stack will be like this. If the top pointer is set to -1, then the stack is empty. Here we are using one pointer called top pointer. If the top pointer is set to -1, then the stack is empty. Then, if you want to insert an element, you need to increment the top pointer to the 0 first. That means stack of 0 STK. Can I take the short form? STK of 0 means first element. What we need to do? We need to insert the element into the stack. Insertion. Insertion of an element is called push. Here we are calling the operation inserting an element into a stack is called push. I inserted one element now. Then top pointer gets incremented to the next position. Stack is waiting here to either take or remove the element. So insertion. Suppose if you want to insert one more element. At top pointer position we are inserting. Now suppose if you want to remove the element from the stack. See, there is only one open end here. In that only we are doing the insertion and deletion of the elements. This is called top end. Wherever the top pointer is there, in that position we are inserting an element. Wherever the top pointer is there, that element we are deleting out. Which is the recent element we inserted? Last inserted element is 20. That is the one is going out first. Deletion operation is called as pop. Did you got it here? Here there is only one open end for the data structure. Insertion and deletion takes place only at one end called top end. Inserting an element at a top pointer position is called as push. Remove the element from the top pointer position is called as deletion. See here, whichever the element we inserted first, that element is going out. Hence it follows last in first out principle. See, which is the first element I inserted? I inserted that element 10 first. Which is the one is possible to remove? Until the 20 remove, 10 is not possible to remove. Did you got it? Then suppose if the stack size is 5. Elements are stored from 0 to n minus 1 because stack is implemented using array. Until remove of the element 50, 40, 30, 20, 10 is not possible to remove. Which is the one is the first inserted element 10. When we are going to remove this one, first inserted element we are removing at last. First inserted element we are removing first. First inserted, that is the last inserted element is going to be first out. Either first in last out or last in first out, both are same. Any one principle you can apply here. What is a stack? Stack is a linear data structure. It is a collection of ordered elements. Here, orderly collection of elements stored in the stack with the principle called last in first out. Last in first out. It is a collection of ordered element. It is a linear data structure. It follows last in first out principle or first in last out principle. So insertion, deletion takes place at only one end called top end. Inserting an element into a stack at a top pointer position is called a push. Removing the element from the top pointer position is called as pop operation. Which element first to remove? Remove the 50 first. Then top pointer gets decremented. Top pointer gets decremented. Top, where the top pointer was there, that element is going to be removed. Remove the 40. Then decrement the top pointer by 1. Then remove the 30. Then top pointer gets decremented by 1. Now the element pointing to the 20. Remove the 20. Then top pointer gets decremented. Then 10 is possible. Now remove the 10. Then 10 also gets removed. Top pointer set to -1. When the top pointer sets to -1, then the stack is empty. It is also called as underflow. It is also called as underflow. When stack is underflow? When the top pointer sets to -1, then the stack is empty. That time we call stack is underflow. Then insert the element. Then where is the position now? Now the top pointer is here. Top pointer reaches to n-1. Top pointer reaches to n-1. When the top pointer reaches to n-1, then the stack is full. Are you getting the concept? If the top pointer set to -1, then the stack is empty. That time we call that one as underflow. When the top pointer reaches to the n number of elements called n-1, here the size is 5. What is the n-1? 4. When it reaches to n-1, then the stack is full. That time it is called overflow. It is called overflow. When the stack reaches to n-1, the given size, reaches to the given size, then the stack is full. That time the message is overflow. Then if the stack is full, is it possible push operation? No. Push is not possible. If I want to push any element, first I should vacate the element with the pop. First remove the element, then you can insert. When the stack reaches to the n-1, then insertion of an element into the stack is not possible. Understand the concept properly, student? If the stack is full, insertion is not possible. If the place is there, then if the top pointer not reaches to n-1, then only possible to insert an element into the stack. If it reaches to n-1, then the stack is full. That time you are not able to insert the element, then display the message called stack is overflow. Suppose if the elements are not there. If the elements are not there, that time stack top pointer is set to -1. Top pointer is set to -1. Is it possible to do pop operation? No. When the elements itself are not there, the stack is empty, pop cannot be done. Remove of the element cannot be done. There is no element to remove. When it is not possible, when it reaches to top -1, then pop is not possible. Just display stack is underflow. Please remember the point. Overflow when it reaches to n-1. Underflow when it reaches to -1. Did you got it? Understood? Then, how stacks are implemented? Stacks can be implemented in two different ways. One is using the array concept and using a linked list concept. Using a linked list concept. For understanding purpose, we are writing a stack in the array representation. Representation of stack is done using arrays. So application, you can write this is the one application. In the array application, stacks and queues can be implemented using the array. Stack and queue can be implemented using the array. So how it will be created? It will be created using a data type. Instead of array name, we are giving a stack name. Stack is implemented using one-dimensional array, and you need to give the size of that. For example, data type may be any data type. Int, I am taking here integer. stk, I am taking as a stack name of 5. Then 5 memory locations are created in the stack. 1, 2, 3, 4, 5. It is set to STK of 0, STK of 1, STK of 2, STK of 3, STK of 4. This is called creating a stack. Creating a stack. And set top equal to -1. Top equal to -1. In the memory, we created one stack. We created one stack. How we created? We created here, can I write here? We created stack. That stack top pointer set to -1. Top pointer set to -1. We created a stack. We created a stack, and that stack is created with assigned with a value called -1. It indicates we created one empty stack. That is your first operation. If you want to perform any operation on stack, first you need to create a stack. Create a stack. Set the top pointer to the -1. Create always empty stack. Create an empty stack and set top pointer equal to -1. Create a stack. Create a stack. You can create a stack using an array, or you can using a linked list. Once we discuss the linked list concept, that time I will explain you how to create a stack using a linked list. But now we discussed array concept. So using array, I have created one stack here and I have assigned the top pointer to -1. That process is called as creation of the stack, called stack creation. What is that? Creating an empty stack and set the top pointer to -1. It is not going to return any value and it not asking any parameter. Then second operation, push. So always push and pop need to be written in the capital letter. Push, inserting or adding a new element into the stack at top pointer position is called push. Inserting an element or adding an element, a new element into the existing stack at a top pointer position is called push operation. Is it possible to insert an element at a -1? No. It gets incremented with a 1. -1 plus 1, it will become 0. Then the top pointer is pointing here. Then insert the new element. Inserting a new element into a stack at a top pointer position are called push. When we are pushing, it requires an element called a parameter. It is not going to return any value. It is not going to return any value, but it takes a value to insert an element at top pointer position. Did you got it? Then again top pointer gets incremented by 1 plus 1. Then the top pointer is waiting for the next element to be inserted. Then if you want to insert an element, another one, it is going to be stored here. Once the inserting an element was happened, then it will be incremented for the next element to insert. Otherwise it will be pointing here. If you want to insert a next element, then top pointer gets incremented by 1 and here it is going to be pointing on that position. Your element is going to be inserted. Then it will be pointing here only until you try to insert the new element. If you try to insert a new element, it gets incremented. Then it is going to be accepted the value and stored in the position. Then if you want to insert one more, then the top pointer is pointing here, top pointer, then 50 will be inserted. and if you try to insert a next element, it is already been reached to n minus 1. If you try to insert a 60, that time it is going to be display called overflow. When the top pointer reaches to n minus 1, then you are trying to insert the new element, that time it is going to display the message called overflow. Did you got it? Then now we are doing with the next operation called pop operation. Both insertion and deletion takes place at only one open end called top end. One open end called top end. See, the element which is present in the top, first it is going to be eliminated. Then decrement the top pointer by 1. Decrement the top pointer by 1. Then element 40 gets eliminated. Then one more, again it is going to be decremented by 1. Then again element 30 gets removed. So once the elimination of the element is done, top pointer gets decremented by 1. Then element 10, 20 eliminated. Then once again, then it is 10 now, it is eliminated. Then automatically top pointer set to -1. When it is -1, if you try to remove one more element, it will display the message called stack is underflow. Stack is underflow. When the top pointer reaches to the minus 1, not n minus 1, sorry, top pointer equal to -1, then the stack is empty. Display the message called underflow. Did you got it? Then suppose the elements are there in the stack. Then the top pointer is here. I forgot how many elements I inserted and I don't know what is the size of the array. Then how many elements it's possible to insert. If you want to know the size of the array, number of elements, how many are there? 1, 2, 3. 3 elements are there, that gives you size. Suppose if you want to know the top pointer position, just to know the top pointer position, there is an operation called PUC. It gives the top pointer position. According to this, it will give you 2 or 3. Stack of 2, not 3. Did you got it? Internal position, it is going to be displayed. That is, to know the top pointer position, we need to perform the operation called PUC operation. Then is full. Just now we discussed, if the top pointer reaches to n minus 1, then the stack is full. When the stack is full, when the top pointer reaches to n minus 1, then the stack is full. That time display the message called stack is overflow. When stack is empty, check whether the stack top pointer is equal to the -1. If it is equal to the -1, then the stack is empty. That time display the message called underflow. Display the message called underflow. Size, how many number of elements are there, that is gives you size. Then traversal, visiting the element from the beginning of the stack till the top pointer position. Till the top pointer position. From the beginning till the top pointer position is called traversing to perform operation. Visiting the elements from the beginning of the list, that is a stack, to the top pointer position. To the top pointer position is called traversal. Did you understood what is stack and the operations of stack? In the next class, we will discuss algorithms related to push and pop and the program related to push and pop. Did you got the student? So along with this topic, so this is possible for 5 mark as well as 1 mark question as well as 3 marks. According to the earlier weightage, this topic is having 1 mark, 3 marks and 2 from the 5 mark questions. So once it was asked, give the operations of stack for 3 marks. Each point is for 1 mark. And once they ask what is peak for 1 mark. What is peak for 1 mark? What is stack? What is stack? Give the algorithm for push and pop. One possible question. What is stack? Write an algorithm for inserting an element into stack. They won't mention the word called push. Insert the element into stack is called push. Remove or delete the element from the stack is called pop. Combine of these two algorithms with the definition for 5 marks. One algorithm is for 3 marks. Only the definitions is possible for 1 mark. Once they ask 1 mark only stack, and along with these two algorithms many times definition was repeated. And once they ask, give the memory representation of the stack. Give the memory representation of the stack. This is a diagram you need to draw along with the example. Along with the example. What is stack? Give the memory representation of stack. This is for 2 marks and the definition is for 1 mark. This much you need to write, and you need to mention that where you are doing a pop operation and where you are doing the push operation, where is the top pointer position. This if you write, then definitely you are going to get the complete marks. Did you got the student? In the next class we will discuss these two algorithms, and lab programs are there. 2 lab programs. Lab programs I am not going to explain on the board because it was more lengthier one. I can't write it here. I will explain with the execution video. And here along with that, one more possible 5 mark question. Applications of stack. Applications of stack. Okay. So this we will discuss in the next class. In the next class, these two algorithms. If time permits, then application. We will finish it by the 2 classes. Okay. Thank you, students.